Hi there. Today we're going to talk about the concept of light reflection. We'll narrow our focus onto just a plane mirror. Now, in physics, a plane mirror means a mirror that is completely flat with no bumps on its surface, so no curves or anything. So here's a regular reflection in a plain flat mirror. Light rays hit the surface and then bounce off. And so regular reflection occurs when the mirror is nice and flat or plain. We sometimes call it specular reflection. As opposed to what? Well, if the mirror or surface was bumpy, like waves on a pond or a lake, then we would get something called diffused reflection, and the light rays don't travel in a very predictable pattern. We say it's scattered. So you're going to do an activity where you set up your array box, which sends out a beam of light, almost like a laser beam, and you're going to use a flat plane mirror, and your ray is going to hit the mirror at a particular point on an angle, and it will bounce off. You're going to change that angle. Now there's important terminology, and one important terminology when it comes to light has to do with this virtual line, this imaginary line. It's called the normal line. And the normal line is always a 90-degree line to the plane of the surface. So this normal line, so here's where the light beam's going to hit. Our normal line we would draw into our diagram would be 90 degrees from the mirror. Other important terms. The light ray coming into the surface we call the incident ray, and the light ray that bounces off the surface, of course, is called the reflected ray. Now, let me draw in the normal line, if I can draw it straight. Oh, it's a little wavy. It's supposed to be straight. Now, that creates, when we draw our normal line, that creates 1, 2, 3, 4 different angles. Angles 1 and 4 don't really have any names, but angle 2 we call the angle of incidence. That's from here to the normal line. And angle 3 we call the angle of reflection. So here's an example of a ray box set up. It's bouncing off the mirror. I drew in the normal line. B is the angle of incidence. C is the angle of reflection. And this, which I just made a star, is called the normal line. A and D don't have any special names. So the angle at which light initially strikes the surface, we're going to find out, is going to be equal to how much it bounces off. Don't forget, we always draw in the normal line. So in all these examples, I've drawn in the normal line, except this last one I didn't. So the law of reflection states, and you'll find this out when you do your experiment, that light strikes the surface at angle A and leaves at angle B, okay, relative to the surface. A and B will always be equal. Okay, don't forget, A and B don't have names, but they will be equal. Light is said to be reflected. So here's the light. It bounces here to our eye. This would be angle A and B. They are not, this is not the angle of incidence. This would be the angle of incidence. And here's our normal line. So A and B would be equal, and C and D in the diagram would be equal according to the law of reflection. So the first law, the angle of incidence is always equal to the angle of reflection. Cha-ching. And the incident and reflected rays and the normal are coplanar. So two important laws. Now that we know what happens to light as it bounces off a flat plane mirror, let's talk about what happens to an image. Images are formed in mirrors and lenses, and they may be classified as either real or virtual. A real image is formed by actual rays of light converging, whereas a virtual image, not formed by actual rays of light converging, but from where the rays of light appear to come. We call these diverging light rays. So let's look at this. If this is a flat plane mirror, all the observers perceive light to be diverging from the same point. In actuality, the rays of light, okay, will bounce off and they head back here. But if we extend dotted lines to the diverging, so we extend to what's happening to the diverging rays, we realize it's a virtual image. Okay, images formed by plane mirrors are always virtual. Okay, they're not formed by the real light, okay, because the light bounces off this way, back here. The other thing we should notice is the following. If you look in a mirror and you hold up your right hand, in the mirror it looks like your left hand. You know, or when you're driving, if you look at an ambulance, it's written backwards for a reason. And it's called the left-hand, right-hand rule when it comes to reflection. Look at this, reflection. So we've done this one already. Let's go past these. So an image will always be upright, not upside down. It'll be the same size. Whoops. Sorry. It'll be the same size as the real. And front and back are reversed. So here's your eye, here's the butterfly. Light rays bounce off like this in a very predictable pattern. This is the virtual image, and light rays cause the butterfly to be flipped. Okay, so let's look at this here. Maybe not. So here's our real image right here. Sorry, here's our real image. No, this is the real one in the mirror. And here's the virtual one. Okay, notice the distance from the mirror is the same, which makes the size of the object the same. These two arrows show you the size of the object are the same. The only thing different is the left to right. Okay, so real objects are the same size as the virtual object. A real object is the same distance, and its left to right is reversed. And that's it for reflection in a flat plane mirror.